start with a familiar scene. You're chatting with a virtual assistant, marveling at how it answers your questions or generates a poem on the spot. Modern AI, like the massive language models behind these feats, is a marvel. Take GPT-4, rumored to have 1.7 trillion parameters, a digital brain so vast. It's like a library with endless shelves. But here's the catch. Building and running these models is like fueling a rocket with coal. A single training run can churn out as much carbon as 5 cars over their lifetimes. That's a lot of juice for a system that, despite its brilliance, still stumbles over certain puzzles. Think of today's AI as a super smart friend who's a genius at trivia but freezes when faced with a complex logic puzzle. For instance, finding the shortest route for a delivery truck across 50 cities. The number of possible routes explodes into a number larger than the atoms in the known universe. It's an exponential problem that overwhelms even the fastest classical computers. Or consider drug discovery, where simulating how a single complex protein folds requires so many calculations that classical systems have to take shortcuts and rely on rough guesses. It's like trying to build a perfect scale model of a skyscraper using only blurry photographs and a ruler. You'll get the general shape, but the crucial details will be wrong. These limitations aren't just technical frustrations. They are fundamental roadblocks to solving humanity's biggest challenges, from curing cancer to combating climate change. We're asking our best technology to solve problems that are, by their very nature, too complex for its architecture. But what if there was a way to rethink computing entirely? As Albert Einstein once said, we cannot solve our problems with the same thinking we used when we created them. Enter quantum computing, a game changer that doesn't just speed up AI, it gives AI a completely new way to think. Quantum AI is like giving your super smart friend a magic lens, one that allows them to see through the most complex puzzles in a single glance. So, how does it work? Let's dive into the weird and wonderful quantum world. Imagine you're searching for a lost key in a massive mansion with 1,000 rooms. A classical computer, as fast as it is, would check every room, drawer, and corner one by one. It's methodical, but it could take days. A quantum computer, however, could check all 1,000 rooms at the same time, finding the key in minutes. This isn't magic, it's the mind-bending power of quantum mechanics. Unlike the classical bits in your phone or laptop, which are always either a 0 or a 1, quantum bits or qubits can exist in a state of superposition. This means a qubit can be a 0, a 1, or both simultaneously. It's like a spinning coin that's both heads and tails until it lands. Now, imagine a computer with hundreds or thousands of these spinning coins, all linked together through another bizarre property called entanglement. Einstein famously called it spooky action at a distance. When qubits are entangled, the state of one instantly influences the others, no matter how far apart they are. This interconnectedness allows a quantum computer to explore a vast number of possibilities at once, giving it a profound advantage for certain types of problems. Quantum algorithms are the instruction manuals that harness this power, giving a set of incredible superpowers. Take Grover's algorithm, which can search unsorted data quadratically faster than any classical method. For an A sifting through massive datasets like genomic sequences to find a marker for a rare disease, this could mean finding the answer in seconds instead of days. Or consider the HHL algorithm, which can solve systems of linear equations exponentially faster. Since so many fundamental AI tasks, like training machine learning models, are built on a foundation of linear algebra, this could slash training times from weeks to mere hours. In 2024, researchers at Google demonstrated this in a stunning way. They showcased a quantum machine learning algorithm that successfully identified patterns in a dataset that were designed to be invisible to any classical AI. It was like giving the AI a new sense, allowing it to perceive a hidden message in a sea of static noise. And then there are quantum neural networks. Think of a classical neural network as a painter with a limited palette of colors. trying their best to capture the infinite shades of a vibrant sunset. They can create a decent approximation, but it will never be perfect. A quantum neural network, leveraging superposition and entanglement, is like a painter with an infinite palette. It can process information in so many states at once that it can model incredibly complex patterns with far fewer components, painting a picture of reality with breathtaking detail and nuance. This isn't just about doing things faster. It's about seeing the world in a fundamentally new way. What if you could predict stock market crashes or the onset of a disease with an accuracy that borders on clairvoyance? That's the quantum AI promise, and it's already beginning to reshape our world. Let's zoom into one of the most profoundly human applications: healing the sick. Developing a new medicine is a monumental undertaking, like searching for a single unique grain of sand on all the world's beaches. It can take over a decade and cost billions of dollars, with countless promising ideas leading to frustrating dead ends. A huge part of this challenge is that classical computers simply can't accurately simulate how complex molecules behave and interact in the human body. They are forced to make approximations, which is why so much of drug discovery is still based on trial and error. Quantum AI changes the game entirely. It's like handing scientists a superpowered microscope that can see not just the atoms in a molecule, but the intricate quantum dance of the electrons that govern its behavior. By accurately modeling these interactions, it can pinpoint promising drug candidates with astonishing speed and precision. Take Pfizer's work during the COVID-19 pandemic. They partner with quantum computing firms to use quantum machine learning to screen and analyze potential treatments. They could study molecular properties and binding affinities at a level of detail that would have completely overwhelmed classical systems. Imagine a scientist facing a virtual library of 1 trillion possible compounds, searching for the one that can perfectly dock with a virus and disable it. Quantum AI doesn't just speed up the search. It can predict with high confidence whether the key will fit the lock before it's ever synthesized in a lab. This capability could compress the timeline for developing new treatments for diseases like cancer, Alzheimer's, or rare genetic disorders from a decade to a matter of months, potentially saving millions of lives. Now, bring this into your own life. What if a loved one is diagnosed with a rare form of cancer? Today, the options might be limited. But in a future powered by quantum AI, a system could analyze their specific tumor, simulate thousands of drug candidates against its unique genetic profile, and design a personalized medicine tailored just for them. This isn't science fiction. It's the future of personalized medicine that we are racing toward. By drastically cutting the time and cost of drug discovery, quantum AI promises to make these bespoke treatments accessible to everyone, not just the wealthy elite. Imagine a world where a life-saving drug reaches a patient in months, not years. What disease would you want quantum AI to tackle first? Now, let's shift gears to the very stuff that builds and powers our modern world: materials. The battery in your phone, the solar panels on a neighbor's roof, the lightweight alloys in an airplane, or the superconductors that could one day deliver electricity with zero loss. All of these technologies depend on the slow, painstaking process of discovering new materials with just the right properties. Traditionally, this is like being a chef trying to invent a new dish by randomly mixing ingredients from a giant pantry. It's a process of intuition, luck, and decades of laborious lab work. Quantum AI flips this script entirely. Instead of randomly mixing, it provides the ultimate cookbook. By simulating the quantum interactions between atoms, it can explore the vast, near-infinite space of possible material combinations and predict their properties before a single one is ever created. What used to take decades of trial and error in a lab can now be simulated in days or even hours. Imagine a battery for your electric car that charges in 5 minutes and has a range of 1,000 miles. Or solar panels that are twice as efficient at converting sunlight into electricity, making clean energy dramatically cheaper than fossil fuels. These aren't just pipe dreams. In 2024, Researchers used a quantum AI simulation to identify a new material for creating more energy-efficient transistors, a crucial step toward greener electronics for all our devices. Quantum AI is accelerating the discovery of these game-changing materials by orders of magnitude. This has profound implications for our planet. Better, cheaper batteries could finally make electric vehicles the default choice for everyone, slashing our global carbon emissions. More efficient solar cells could power entire cities and industries sustainably. Quantum AI can also help design new catalysts to pull carbon dioxide directly out of the atmosphere, or to produce green hydrogen fuel more efficiently. It's a powerful tool in our fight against climate change, offering tangible, science-based solutions. Picture your daily life, an EV that almost never needs charging, a home powered by ultra-efficient solar, gadgets that last longer and use less energy. How would a truly revolutionary battery change your daily routine? Speaking of the planet, let's explore how quantum AI could help us understand and protect our fragile climate. Today's climate models are incredible feats of science, but they are running on classical computers that have their limits. They are forced to simplify enormously complex systems, like the turbulent flow of ocean currents, the formation of clouds, or the intricate chemistry of the atmosphere. These simplifications create uncertainties, like trying to predict the weather using a blurry, low-resolution photograph. This makes it harder to know exactly how climate change will impact your specific city or region. Will it bring more intense floods, longer droughts, or deadlier heat waves? Quantum AI could revolutionize climate science. By harnessing its ability to model complex, interconnected systems, it could simulate Earth's climate with unprecedented detail and accuracy. Instead of just predicting a global average temperature rise, a quantum power model could tell you precisely how warming oceans will affect local rainfall patterns in your state, or which crops will thrive and which will fail in your region in 20 years. It's like upgrading from that blurry map to a live, interactive 4K satellite image of our planet's future. This level of precision could be a game changer for policymakers and communities. It could guide decisions on where to build resilient infrastructure like seawalls, how to manage water resources in the face of drought, or which ecosystems are most at risk and need protection. In your own life, this could translate into real safety and security. Imagine receiving a hurricane warning not days, but weeks in advance, with a highly accurate prediction of its path and intensity, giving your community ample time to prepare. For farmers, it could mean knowing the optimal time to plant and harvest to maximize yield and avoid climate-related losses. Quantum AI is poised to turn climate science from a field of educated guesses into one of precise, actionable predictions. What if you could know with high certainty how climate change will reshape your hometown in the next 30 years? How would you and your community prepare? Now, let's talk about something that touches all of our lives: money. The global financial system is a dizzyingly complex web of interconnected markets, assets, and risks, all moving at the speed of light. It's a high-stakes game of balancing risk and reward. And while classical AI has made huge strides in this area, it still struggles with the sheer complexity and randomness of it all. Quantum AI, however, is tailor-made for this kind of challenge. Its ability to analyze a massive number of variables and potential outcomes simultaneously is a perfect fit for finance. Financial giants like JP Morgan Chase and Goldman Sachs are already investing heavily in developing quantum algorithms to optimize investment portfolios and predict market volatility with an accuracy we've never seen before. It's like having a financial advisor who can not only see the current state of the market, but can also simulate every possible future at once. Consider the classic problem of portfolio optimization, choosing the right mix of thousands of stocks, bonds, and other assets to maximize returns while minimizing risk. A classical computer might take hours to run through the calculations, and even then, it can only provide an approximation of the best solution. A quantum algorithm could explore the countless combinations simultaneously, finding the truly optimal portfolio in seconds. For you, this could mean better returns on your 401k, a more secure retirement fund, or lower risks for your personal investments. In 2024, several research papers showed quantum algorithms outperforming their classical counterparts in predicting stock market trends and pricing complex financial derivatives, offering a glimpse into a future where financial decisions are far sharper and more robust. This extends beyond just investing. Quantum AI could be used to detect sophisticated financial fraud in real time or to more accurately model economic risks, helping to prevent the kind of financial crises that have shaken the world. For you, this translates to greater financial stability and security. Imagine a personal finance app powered by quantum AI that helps you navigate the complexities of saving for a house, funding your child's education, or planning for a comfortable retirement with unprecedented confidence. What if you could trust that your financial future was being guided by an intelligence that could account for nearly every possibility? With such immense power comes equally immense responsibility, and quantum AI is no exception. This technology is a classic double-edged sword. On one side, it holds the promise of world-changing breakthroughs that could elevate all of humanity. On the other, it presents new ethical challenges that we must navigate with wisdom and foresight. The first major concern is access. Building and maintaining a quantum computer is incredibly expensive and complex. This raises a critical question. Will quantum AI create a new quantum divide, widening the gap between the technological haves and have-nots? If this power is concentrated in the hands of only a few wealthy nations or mega corporations, it could lead to an unprecedented consolidation of economic and scientific dominance. But there is a powerful counter-movement afoot. The rise of cloud-based quantum computing, offered by companies like IBM, Amazon, and Microsoft, is democratizing access. Researchers, startups, and even students from anywhere in the world can now run experiments on real quantum hardware. Open-source software libraries like Qiskit and Pennylane are empowering a global community of developers to learn, innovate, and contribute to this field. Imagine a small or creative startup in your town using a cloud quantum service to design a new, hyper-efficient water purification system. That is the promise of accessible technology. Then there is the profound question of AI safety and alignment. If we create a quantum AI that can solve problems far beyond human comprehension, how do we ensure its goals remain aligned with our values? How do we build guardrails for an intelligence that operates on principles we are still struggling to fully understand? These are not future problems. They are present-day challenges that researchers in AI ethics are working on right now. Developing robust frameworks for transparency, control, and value alignment is just as important as building the hardware itself. For you and for all of us, this means fighting for a future where this incredible technology serves all of humanity, not just the powerful. How can we, as a society, ensure that everyone gets a seat at the quantum table? So, what can we take away from this incredible journey to the quantum horizon? Quantum AI teaches us that the limits we perceive are often just a product of the way we think. For centuries, we built our world on classical logic, on O South and One South, on definite states, on cause and effect. Quantum mechanics showed us that at the most fundamental level, reality is far more strange, probabilistic, and full of potential. So, I'll ask you again, but with a new lens, what problem in your life would you love a new perspective to solve? It doesn't have to be a global issue. Maybe it's a creative block, a relationship dynamic, or a personal habit. How could thinking about it in a completely new way, a quantum way, unlock a future you haven't yet imagined? If you're as excited about this quantum revolution as we are, hit that subscribe button to join us on this journey through the technological frontier.